So now we'll discuss about interfacing examples. So under this we have three things. So how 8051 microcontroller interfaces with the external memory via the 8255 ports, and how we are going to interface with the LEDs and switches and 7 segment display. So coming to the first interfacing example, interfacing 8255 with the 8051. Already we know that 8255 is the programmable peripheral interface, and it is provided with three input ports: port A, port B and port C. And here when you come for interfacing 8051 with the input output devices via the 8255 ports, port 0 in 8051 is used to carry the low order 8 bits of address or the data bus, and port 2 is used for carrying the high order address. Port 3 is having some alternative functions such as receiving interrupts like that. So only port 1 is used for input and output operations. The interface of 8255 with 8051 is done assuming the memory addresses for 8255 ports. Assume addresses 8000H to 8003H. And here in 8055 we have 4 registers. One is for control word register, the other 3 are for port A, port B and port C respectively. So this diagram shows the interfacing. So in 8051, port 0 and port 2 are used to send the addresses to the 8055, and port 3 is used for carrying the input and output operations. The read operation for 8255 is generated from P3.6 port, and P3.7 is used to generate the write address for the 8255. The decoder is going to generate the chip select signal for this 8255. Now coming to the control word register, first now we want to use port A for reading purpose, and the data read on port A is used to write on port B and port C. So now in order to program the 8255 ports like that, we need to write the control word register. So already we have seen the control word register format. It is an 8-bit, and to say that it is going to operate in IO mode, the first bit D7 is set to 1, and D0 is used for port C lower read or write. D1 says port B read or write. D2 tells what is the mode of group B. Since we are going to use simple IO operation, it is set to 0, and port C upper is also used for only output purpose, so it is 0. Port A is used for input, so it is set to 1, and D5 D6 bits tells group mode of group A. Since there are 3 modes possible for simple IO, it is 0 0. So the bit pattern is in hexadecimal is written to be 90H. Now with this control word register, we can go for writing the program where the 8051 microcontroller is going to read from port A and write onto port B and port C. So in 8051 microcontroller, move is used to transfer the data within the internal memory, whereas movex is used to transfer the data in between the internal and external memories. So this is what the program. First, the control word register is written to the move to accumulator A. So hash indicates the constant. Since already we have written 90H, that is moved to A, and the address of the external memory is pointed by the data pointer. So first we need to place the address of the control word register into the data pointer register. So that is done by the second instruction, move dptr comma 800H, and then we are going to move the contents present in the address onto the we are going to read from that. So that's what we are doing at the rate dptr comma A. That means the 90H value is written onto the control word register pointed by the data pointer register. And after that now we are going to move the address of port A, which is 8000H, to the data pointer, and MoveX, it is used to read from the input port A, And since the port A address is already stored in DPTR, now we are going to read from port A onto the accumulator A by the instruction MOVX A comma at the rate DPTR. Now this value has to be written onto port B and port C. Port B address is 8001 and port C address is 8002. So move data pointer, the address of port B hash 8001H, and that to that address we are going to write the contents of accumulator MOVX at the rate DPTR comma A. Then we are going to write to port C. Port C address is 8002. Since already port data pointer contains port B address 8001H, if we increment that data pointer, it points to port C, and we will write that contents of port A accumulator onto port C. So that's how the 8051 microcontroller interfaces with the 8055 ports. Thank you.